Okay students, welcome to another class. So today we are going to redraw the flanged coupling. Basically the objective of this lesson is to be able to read and interpret the assembly drawing. The isometric view of the protected type flange coupling is given. We will read the dimensions from that and we will draw the front view and the side view. It is a sectional front view and side view for the assembly. I will use AutoCAD for drawing. So first let's understand the dimensions, what is given in this question. So we need to look into this. This is part of your question. This is also given, but we have to now interpret the dimensions. Only one flange is given here and they are showing the sectional view for this. The other side flange is not shown here. We can see there are two flanges. The flange is basically two, and this is a coupling to connect two shafts. So one flange on one side, another flange on the other side. The dimensions are given only for one flange. We assume that it is almost similar mirror image of this flange, the other side flange. So let's see the dimensions. As you can read from the drawing, the total diameter here, this is 200. As you can see here, this is 200. The diameter, the largest diameter for this is outer diameter for the flange itself, 200. So we'll take from here to here 200. You can offset from the center 100 for that. Then this one here, this is 100. As you can see here, the dimensions. So we have to read the dimensions from this drawing and then draw this view. We have to redraw this view and also we have to draw the side view. The shaft diameter is given as 50. Shaft length is not given, but the diameter of the shaft is 50, as you can see here. So like this, you have to read the dimensions from here and understand where to implement it in the drawing. The 40, this is 40 coming from here, as you can see. This 40 dimension, one side, one flange is 40, another side, another flange also will be 40. So this 40 is given here. In addition to that, the total length here from this face of the flange to the end of the flange is 75. Here slightly different, we'll talk about it later, but this is 75 total from this end to this end. As you can see, it is shown here 75. So this is 75 from here to this end. Now it is a protected type flange coupling, means the bolt and the nut is protected inside the housing of the flange, and this here the thickness, the cross section thickness of this is 22. The total is 40, this is 22, so the remaining will be 18, right? 40 minus 22. Now this is having a little taper here. As you can see, this they are saying the thickness here is 6, whereas by the time you reach here it is 8. So this is 6 here, and by the time you reach here, that the wall thickness 22 area here, it becomes 8. So it is tapered here, it is increasing in the thickness. Generally this is done for the ease of casting, when this is made by casting, and for the easy removal. This is for the manufacturing process, they give the tapers here. Next dimension is the hole diameter. It is given diameter 16, 4 holes. So in this hole we are using the bolt and the nut. So major diameter of the bolt and the nut, M16, right? So major diameter will be 16. So from that we have to calculate the size for the hexagon, 1.5 into 16 and so on, like what we did in the previous labs. So this is M16 bolt and the nut is to be used here. We will use the simplified representation. Okay, we will use the simplified representation. In the question in the lab it says schematic representation, but we will use simplified representation. The end also is shown a little bit easy way here. Just from the major diameter, just draw some arc. 70. Now where is this hole for the bolt? The PCD of this is given 140. 140 is a pitch circle diameter for these holes, the 4 holes here. 140 is the distance for given diameter. 140 is for the center of these 4 holes. So from the center, half of 140 is 70. So this distance for this axis of the hole is the center of the hole is 70 from the center of the shaft, 70 from here. So another side is 70 plus 70, 140. And then let's look at this small area here. This is very interesting. Now for the proper alignment, because proper alignment is important for the operation of the coupling, otherwise there will be more vibration. So proper alignment is not generally achieved by the threaded fastener. They are there to hold the parts together. The alignment is done by this one. What is this here? It's like one flange is having a small hole. The depth of the hole here is 5 milli, as it is given here. The depth of the hole is 5 milli. So depth of the hole is 5 milli. You can see this is 5 milli distance here. This one here, this one to this one. This is 5 milli. Okay, this 5 milli. And then the other side flange is having like the projected or protruded area, the area which is coming out, cylindrical area which is coming out, and that is going into that hole of 5 millimeter depth. And there is some clearance also here, so it is shown. So we can assume this clearance is equal to 2 millimeters, and this is going inside by 3 millimeters. We can assume that distance. Only we know the depth is, total depth is 5 millimeters. And what is the diameter for that? It is given 90. Okay, so from the center it will be 45 up to here. From the center 45, half of this 90, and this is 5 milli, and we can assume the clearance is equal to 2 milli. So it will give you, suppose you control the size of this hole here, and you make the interference fit like this, you know, it will be very tight fit. It cannot come out, right? So it will be tight fit, interference fit, so that it will ensure proper alignment between the two shafts. Let's look at the key. They are saying key is a rectangular key 16 by 10. So this dimension for the key is 10, and this is W is equal to 16. The length of the key is not specified. It is not important. We can assume it as a 75. You can just come out a little bit from here. It's up to you. So we can assume 75. You can see there are two keys. One key is here on this side and another key is on this side. So here the dimension is 10. So 5 up and 5 down from the shaft line here. Whereas here the top view of the key is shown. So this is 8, 8, and in total distance here will be 16 for the same key. So in one view you are looking at the front view of the key, another view you are looking at the top view of the key. So that's it for the dimensions, and now we will start drawing it in the AutoCAD.